Now we're going to look at tables and coordinates. And this time we are given the information that the functions we are looking at are, in fact, linear functions. So knowing that they're linear, we need to find the missing value in the table or in the ordered pair coordinates. So let's look at example 1. What is the missing y value to complete the table of the linear function? So again, I'm going to go ahead and underline that word linear because that tells us that this should have a constant rate of change. So we need to figure out what is the rate of change, what is the slope. Remember, rate of change or slope is rise over run, or change in the y coordinates in the numerator over change in x coordinates in the denominator. So let's calculate the change in the y coordinates first. So if I go from this first point, negative 5, 8, to the second point, my change in y coordinates is minus 1. Then if I look at the change in my x coordinates, it looks like to go from negative 5 to negative 3, I'm actually adding 2. So that means this linear function, since I know it's linear and I know that it has a constant rate of change, my slope is equal to negative 1/2. Okay? So I'm going to follow that same pattern to find the unknown value. To go from negative 3 to negative 1, I'm going to be adding 2. So that means I'm going to go ahead and subtract 1 again, following that same pattern. 7 minus 1 is 6. So the unknown or the missing y value in this table would be positive 6. Now we're going to look at example 2, which could be written in a table, but this time we have it written as coordinates. Okay, so once again, we know that it's linear. So we're going to figure out the rate of change or the slope. So let's first do the change in y coordinates. So I'm going to look at the 20 and the 6. To go from 20 to 16, I subtracted 4. And now I'm going to look at the x coordinates. To go from 0 to 5, I added 5. So since this is linear, my slope or my rate of change is going to be negative 4/5. I'm going to follow that same pattern and use that same slope to figure out the missing y value in this coordinate. So to go from 5 to 10, I added 5, which means to get from 16 to the unknown value, I'm going to subtract 4. 16 minus 4 is 12. And one way that you could check your work would be to actually graph these points on a coordinate plane, but I know that that takes a lot of time, so you may not want to do that. Okay, last example. What is the missing y value to complete the table of the linear function? Again, we are told that it's linear, so that means the rate of change is constant, or the slope is going to be the same throughout the table. So let's figure out what is our slope. To go from 0 to 2, I am adding 2. To go from 1 to 2, I am adding 1. Remember, the change in the y is the numerator, so that's going to be a 2 in the numerator, and the change in the x coordinates is the denominator, so that's a positive 1. So that means my slope is 2, or 2 over 1. All right, then to go from 2 to 4, I'm adding 2. To go from 2 to 3, I'm adding 1. So again, I have that slope of 2 over 1. So let's just keep going with our pattern here. So from 3 to 4, I add 1. And then from 4 to the unknown, I'm going to add 2. 4 plus 2 is 6. So that means the missing y value in my table should be a positive 6.